Hey everyone, and welcome. Today we're diving into a really special explainer. Think of this as a masterclass on the absolute coolest parts of artificial intelligence and its evolution. Now, we aren't just looking at the history of giant, isolated computer brains today. We are going to explore a massive paradigm shift. We're talking about the move from solitary, classical AI to decentralized, collective swarms. Because, as you'll see, the future of problem solving is actually inspired by communities, not just individuals. It's going to be a fun ride.
So here is our roadmap for today. First, what is intelligence? Second, the evolution of AI. Third, the limits of the centralized model. Fourth, distributed artificial intelligence. And finally, the power of collective systems.
Section 1. What is intelligence? Philosophical foundations. Okay, before we can even begin to build artificial intelligence, we kind of have to figure out what the intelligence part actually means. So, what is intelligence? It sounds like a totally simple question, right? But the truth is, even the greatest minds throughout history have genuinely struggled to agree on a single, unified answer. Let's look at how a few different visionaries have tackled this. First up, we have Alan Turing, one of the undisputed fathers of computer science. He looked at intelligence purely through the lens of tasks and outputs. For him, if a machine could perform a task so well that you literally couldn't tell if a human or a computer did it, well, that was intelligence. It's a very mechanical, operational view, and it heavily shaped early computing. But let's contrast that with Charles Darwin's view. Darwin shifts us completely away from tasks and into biology. For him, intelligence isn't about passing a math test. It's about adaptation. It's whatever allows the fittest individual to survive in a constantly changing environment. It's a strictly evolutionary, survival-based definition. And then we have the ethologist Konrad Lorenz, who gives us a completely different piece of the puzzle. Lorenz argued that intelligence is collective. He said it actually emerges from collaborative behavior. So the crucial point here is that intelligence doesn't have to live inside a single brain. Keep this idea in your back pocket, because this collective theory is purposefully planting the seed for what we're going to talk about later with ant colonies and modern AI.
So if we synthesize all of these perspectives, we see that true intelligence requires some very specific capacities. It's the ability to react with flexibility to new situations, to distinguish meaning even when things are super ambiguous, to judge what is relatively important, to find similarities, and to combine old concepts into brand new ideas. This flexibility and judgment, that is exactly what we try to replicate in machines.
Section 2. The evolution of AI. A brief history.
Right, so how did humanity actually try to build this intelligence? Well, it all started conceptually way back in 1936 with the Turing machine. By 1956, the term artificial intelligence was officially born at the famous Dartmouth Conference. We then saw this massive, active period of creating languages like Lisp and early robots like Shaky. By 1969, we entered the era of expert systems like Mycin, which could actually diagnose blood infections at the level of human doctors. Incredible stuff. Fast forward to 1997, IBM's Deep Blue beats chess champion Garry Kasparov, leading us right into 2011 and beyond, which is the modern era of deep learning and big data. But notice the trend here. For decades, the absolute goal was building one massive, highly capable central brain.
Section 3. Limits of the centralized model. The wall of complexity.
But here is where we hit a massive roadblock. These centralized visions, they eventually hit a hard wall. We reached the limits of classical AI when applications started needing multiple types of expertise all at once. You see, we simply cannot scale a single centralized processor infinitely to handle the overwhelming complexity of the real world. It would overheat, bottleneck, or just flat out crash trying to do everything at the exact same time.
So why must we distribute intelligence? Well, look around us. We have massive demands for higher connectivity, bandwidth, and integrated complex systems. And more importantly, the real world itself is physically and functionally distributed. Think about air traffic control networks, or designing a complex product like a car, which functionally requires dozens of different specialists. A single brain literally can't be everywhere at once. Modern challenges demand a completely new architectural approach.
Section 4. Distributed artificial intelligence, the paradigm shift.
And that brings us to a massive paradigm shift, a real game changer. We are moving from the centralized system, which is basically the isolated thinker hoarding all the data and processing power, to the decentralized system, a community of thinkers. Instead of a solitary genius machine, we are now dealing with a cooperative community building solutions together, fully distributing the knowledge and the control.
So what exactly is distributed artificial intelligence, or DAI?
Well, it's formally defined as the study of autonomous entities interacting with each other and their environment to build solutions via collaboration or competition. The absolute crucial takeaway here: knowledge, control, and physical space are distributed rather than centralized. Cooperation isn't just some nice-to-have feature, it is absolutely indispensable for solving problems in DAI.
Now within DAI, there are two fundamental branches we really need to contrast. On one side, we have distributed problem solving, or DPS. This is very top-down and static. It's basically just dividing up a big problem into smaller modules where each part has partial knowledge. Pretty straightforward. But on the other side, we have multi-agent systems, or MAS. Now, MAS is completely bottom-up. It's social-centered and relies on emergent resolution. This is true social collaboration, not just dividing up a chore list.
To define it clearly, a multi-agent system is a branch of DAI that coordinates autonomous agents to solve problems collectively from the bottom up. This is the very foundation of modern emergent problem solving. Instead of a master controller dictating every single move, you have independent agents negotiating, cooperating, and adapting on the fly to get the job done together.
Section 5. The power of collective systems. The wisdom of the swarm.
Now, this bottom-up idea sounds incredibly complex to program, right? Well, nature actually figured it out millions of years ago. Just look at insect colonies, like ants and bees. They can perfectly coordinate thousands of individuals without any central supervisor whatsoever. There is no CEO ant giving orders from a corner office. Yet they build complex bridges, forage for food super efficiently, and defend their nests simply by interacting locally with one another.
And this brings us to a beautiful, almost magical concept called emergence. Emergence explains how complex collective cognitive capacities arise from the highly limited individual capacities of entities within a system. Think about it for a second. A single ant has a very, very limited capacity to plan or reason. It cannot master a complex overall plan for the entire colony. Yet, when you put thousands of them together following simple local rules, a brilliant, highly functioning society emerges out of nowhere.
So, let's quickly review the 3 core traits that make swarm intelligence vastly superior to a single, fragile, centralized brain. First is flexibility. The collective system easily adapts to unexpected environmental changes. Second is robustness. If one ant fails or one node in a computer network goes down, the colony functions perfectly fine. The system is completely unbothered. And third is emergence, the ability to scale profound intelligence from very simple, limited parts.
We've journeyed all the way from Alan Turing's vision of a single intelligent machine to understanding the decentralized wisdom of ant colonies. And so I want to leave you with this provocative question to chew on. If simple ants can build incredibly robust, adaptable systems together from the bottom up, how will decentralized collective artificial intelligence change the future of our own human society? From classical AI to the power of the swarm, the future isn't just artificial, it's collective. Thanks so much for exploring this explainer with me today. Keep learning, and I'll catch you next time.